Hi everyone, Dixie from ATK, and thanks for joining us for today's webinar, Collaboration for Civil 3D. Technical consultant Dean will be presenting for us. So first we'll just go through about ATK, all about fostering innovation through consulting and training. ATK Technologies plays a vital role in helping infrastructure, building, mining, construction, architecture, and manufacturing industries reach their full potential by delivering complete technology solutions and support services such as education, consulting, and IT managed services. We work with visionaries to shape the future of design and in turn enable them through innovation to minimize risks, improve productivities, and achieve excellence. ATK Technologies is considered the business partner of choice and trusted advisor by vendors and clients. We partner with major software and hardware vendors to meet our clients' technology needs. We strive to exceed client expectations by understanding the challenges and delivering solutions through experience and innovation. We work with clients and companies of any size nationally and abroad. Over to you, Dean.
Thanks, Dexter. All right, so the plan for today. If you've read the blurb on what this webcast was about, this is just a bit of a cut down version of that. Now, when you see a lot of webcasts these days talking about collaboration with Civil 3D, it's all about using BIM 360 and ways to work with other people that are using Civil 3D. The idea behind this little webcast is to say, well, okay, what if we don't specifically want to do that, but we want to talk with other people using other Autodesk software, and how can we translate data one between the other and back again? So the workflow we're going to be looking at, and you don't have to use the whole workflow. Any parts of it are obviously usable at any stage, is to start off with Infraworks, which is preliminary design, and then transfer that data through to the design in Civil 3D. From there, we can look at bringing some 12D data in as well, if you have that and need to incorporate it. And then that would be able to work with the rest of the AutoCAD AEC collection, or Autodesk AEC collection. That sort of data can be incorporated, it just needs to be rebuilt, basically. Then we'll be looking at working between Civil 3D and Revit and getting those two coordinated, working together, seeing Civil 3D and Revit, seeing Revit and Civil 3D. Then taking all of that through to Navisworks, so we can see everything compared together in Navisworks as well, where you do your clash detections and things. And then round trip everything back into Infraworks at the end for things like public consultation of your proposed projects, etc. So it doesn't look like much on paper, but it's going to take a little while to get through, so better make an immediate start and get into the demonstration. So this will be a live demonstration, starting off in Infraworks. Now, for those who haven't seen Infraworks before, it's a bit of a Google Earth sort of interface, and you can get a model like this built for anywhere on the planet. It all comes from publicly available GIS data. Some of the buildings are already in here. Yep, you can see a few down here. Some residential as well. Mostly they're going to be the large factories and public buildings, those sorts of things. In the middle of town, there'll be a lot of buildings. More on the outskirts, this is Hobsonville, the old Hobsonville Air Base in Auckland, in New Zealand, which is where I'm broadcasting from, New Zealand. And they're not specifically here. And then you can take a model like this and add to it, build your own buildings and things. And in this area here, I've actually got a previous Civil 3D road placed into here previously, and built a bit of a display or a visualization of what it will be like once it's complete. So that's the sort of thing we're going to be aiming at doing in the end, but we'll walk you through the process. So first of all, this is used for preliminary design. Now this may be lagging behind a little bit on your screens because of the high visual content in Infraworks, but hopefully that won't, we won't be in here for too long to begin with. If you've got questions as we're going through, you should see on your little webinar toolbar, there is a chat area. You can want to put in questions in there. There may be a couple of people online, I think, who might be able to answer those. If not, I'll have a look at those at the end of the session, if we've got a little bit of time there. So to start off with, let's look at sort of moving the subdivision out into this area here, just for those who haven't seen Infraworks before. So we can take these elements that we put in there. I can duplicate them. So I'm going to put a wall over there next to the house, and I'll move this one, I think, as well. So let's say there's a right of way down there we can use. I don't know how wide it is, so I can move this again later on. We can demolish some of these trees. I'm just going to delete those out and make space for this new piece of road. Okay, we go up to the create a component road. And what assembly do I want? Actually, I think it is that one. Yeah, we'll take that one. And simply start laying it out. This is like a great big 3D sketchbox, basically. So I'm going to go to there. Oops, I wanted to go a little further than that, but never mind. And then we can do things like change the elevations of the road. That's gone down a long way, which is interesting. So what we might want to do is bring up a profile. Actually, I'll delete that one off. So you can just delete them if you make a mistake. Delete key. There she goes, and do it again. Component road, that's the one. I actually wanted to run it all the way to the back, so I'm going to start there. I'm going to run to about here. I'm going to give it an angle. Now it's got, trying to put some curves in here for us. So and you can see we're actually using the Ostroads metric because I've got the country kit loaded. So it's looking at the Ostroad standards for a 45 km/h road. I'm going to actually just put a curve, no spirals. There we go. There's our curve going in with the radius it wants. I'm going to go to there. And as you join into another road, you see it'll snap and make an intersection, which is all nice. I do want to look at the levels of that a little bit because it started down very low. I happen to know that's because we've got a new surface put in here. The existing ground is actually down low. So we can actually pull in a profile view, which is the long section. Have a look at that. If we slide into that area there, we can pull her up a bit. And hopefully, if it's the right end, I think it is. Pull that end up so it's a bit better level. And probably come up a little bit more. Yeah, it's not bad for a start. Okay, and in the middle here, if we wanted, we've got our whole length of the road here. There we go. We can come into the middle and say add a vertical curve. And if we want, we can start adjusting the levels in the middle. So it was a little bit down underground there, so I'm going to pull it up. Get it more in line with the ground surface. Okay, so sketching basically to get a preliminary design in this piece of wall. We might want it a little bit shorter because it's crossing over the road there. And you can play around with those, move them sideways, etc. All right, so that's fine. Let's look at doing a couple more roads. Let's do one up here. So again, I'm going to use that same component road. Going to, there we go. Right, and we're using the same assembly, and we'll just snap it to there, to there. This time I'm going to call it a local road rather than arterial. Okay, and I'll put different radii on it. So this one I'm going to put down to here. Again, I'm going to go just a curve, simple curve, and put that through to there maybe. And you can see it makes nice intersections and things for us. And one more. Just connect it directly to that one. All right, and we can change the levels of those other ones as well. It's going to need to on this one anyway. So let's pick up the end of that. Should be the start end, I think. There we go. Let's heal that a bit. Yep, that's healed it. Okay, so in these ones, if we don't want these are going to be local roads, so probably don't want the median in the middle of those, so I can actually pick the median there. Pick it again. There should be 2 sides to it, I think you'll find. No, too close to the intersection there, let's try it here. And because they're component roads, you can just delete the bits out you don't want. Delete that bit of median and the other one. And it heals the intersections and things to make it all good. All right, and I might do the same on this just for consistency's sake. That one. And that one. All right, so we want this preliminary information transferred back to Civil 3D. Now there is an intentional mistake. In these, there is a thickness of one of these lanes has been put in wrong, but it's about 2 meters deep or something. But that's okay. That'll be interesting to see if that goes back to Civil 3D or not. So we can play around, we can style these up, we can talk with the client and get everything looking right. We can change the positioning of the intersection, yield lines and things like that. Even if you don't want them, I suppose. You could get rid of them too, some of the road marking, all that sort of stuff can be changed. All right, so we want this information to go back to Civil 3D. Now, the Civil 3D can read one of these models directly, or you can make what's called an IMX file. But it actually probably makes an IMX file, I'm pretty sure, by itself in the background anyway, when it does the direct read. So I'm going to do the share here to make an IMX. This file type was specifically made for transferring this data between Infraworks and Civil 3D. So I'm going to go around that area maybe here. And all right, that's the area I'm interested in, taking back to Civil 3D. We want to give it a coordinate system. This one's in Auckland, so I'm going to give it the coordinate system of Mount Eden 2000. And where do we want to save that? Let's save it in, yeah, here we'll call it the webinar. Export and put webinar 2, okay. And export it. So just while that's doing that, if anybody's interested and wants it and is using this already, this is my little model I made to show off my little animated helicopters. So if anybody wants the animated helicopter, let me know and I can send you that model to put in your Infraworks. All right, so let's go to Civil 3D now and read in that file. So in Civil 3D, you've got the Insert tab in the ribbon, open an Infraworks model, and we can just go, sorry, you click on that icon for open an Infraworks model. And up here, you choose what you want to open. Now, it could be an SQLite if you're going to read these a model directly. I've done the IMX export, so we just change the file type down the bottom to IMX. Navigate to where it is, which will be desktop. Yep. Why isn't that in order? Webinar 2. And there's my webinar IMX I just made. Go and open that. It needs to have a coordinate system in the drawing, so I'm just going to match it to the one I've exported. And we could just bring in the bits we want, but I'm actually going to bring in everything that's in that little file and go open model. So refined selection set allows you to just choose the bits that you want. But I'm going to bring the whole thing through. There is a big harbour polyline here, which is not what we're particularly interested in. What we're interested in is this area here. Now it's brought through those roads, as you can see, as corridors. So if I pick that corridor and have a look in the object viewer, you will see that we've actually got that mistake has come through. The 2 metre deep thick pavement material has come through, so that it actually does a good representation of the actual cross section of the roads out of Infraworks. However, these batter slopes are not right because they're actually targeting the existing ground surface. I want to target my subdivision surface, which is a modified surface. So we can find those surfaces. They've come through as well. Now, before I do that, well, actually, we'll do this first. So it's going to be the existing ground I'm not particularly interested in. That's the old ground that came from the Infraworks model originally, which is low resolution. I'm going to put that on no display just so it hides it for the moment. Okay, and this is the one I'm actually interested in. And that I will just rename to be Subdivision. And go okay. All right, so that's the one we want to have the corridors targeting. So we simply pick a corridor, edit targets, that area, and tell it to hit the subdivision. Now, if you were using this existing ground, you wouldn't have to do this, but chances are you will have a better survey. You would have put it into Infraworks anyway, and you would tell it to target that once it comes into civil here. And there you go. Let's see, that's looking much more representative of what we actually had in Infraworks. And there's also an alignment in the middle of here. So it's put it with those component roads, it puts a real alignment, and that comes through here. Same radio and everything, the positioning. It also has, if we can have a look at it, a profile, or number of profiles, in fact, in there. And if we go and display that, that 580 is actually the design profile that I drew. So it's already on the design style. And let's put it on a conceptual design style. Going to create the profile view. I'm just going to put it up here for now. And there's the profile we actually made in Infraworks. That's come through as well. So these are all good starting points for where you can start doing the detailed design based on what you've sketched. There's also a bunch of assemblies in here. So that's the intentional mistake. These are not full sub-assemblies, so you want to swap these out, but they're a good marker, a placeholder for when they come through from Infraworks, and then you replace them with full ones to do your full design. So that's all good, and we can do the rest of these as well. So just go edit targets, subdivision. Okay, for the intersections themselves, you'll see that in a minute. Okay, and I'm going to save this drawing. On the desktop for now, called webinar. Okay, the intersections themselves, basically the curb radius has come through. So it gives that as the indication of the radius that came through from Infraworks there. You can play around with those and change them in Infraworks, which is why those are there. All right, so that's all very good. The next thing and it's obviously you go through and do your detailed design at that stage, and you can then take it back like I have with this road that we saw in Infraworks before and display it. And we'll have a look at some of that process towards the end. But the idea now would be, okay, well, or the next thing in the list of things we're going to look at was to say, okay, well, maybe we've got some data from another piece of design software. It could be 12D, could be MX, something like that. A surface is probably, or is the best thing to bring through. Now, there is an old tool for reading in 12DA files. Probably these days, pretty much the only thing you can get out of that is a few string lines and a surface anyway. So you can bring through surfaces that way, or you can bring them through manually. So, and that would be just an export as a drawing file, a DWG out of 12D of 3D faces. And that's what I've got right here. So in this particular model, we can go and insert. I enter an insert command and just the AutoCAD insert. Now down, we don't want to change its positioning. It's in the same or a survey coordinate system already. We want to exploit it so it's individual components, and we will click this button here to go and search for it, and it is under webinar 2. Start files, 12D drawing export. Okay, so having selected that, it just jumps straight in. And we've got individual 3D faces here, and we've got a batter slope on it, and we've got a boundary. Now, boundary would get exported as well if you ask for it. So we've got a bit of a platform here to put a building on, is the idea. So we need to convert that before we can actually use it with the rest of the Autodesk products. We need to convert it into a Civil 3D surface. So to do that quickly, we're going to create a surface. We'll call it platform, 12D platform. From 12D. And we'll put it on a triangulated style, I think, which will be triangles magenta. And so we go and find it over in the tool space, and we add to it the triangles, the 3D faces, maintain the edges of the 3D faces, go OK, select all of those, go enter, and it creates them, creates it as a surface now, one object when I pick it, and we'll put a boundary on it as well. And so it is definitely worth asking for a boundary. It just makes it so much easier than having to do it manually. It's going to be a trim boundary, so it's non-destructive, and we go and pick it there. And that should be it. Let's check in the object viewer. Looking good. So we've got little batter slopes on there, a steep one for the cut, a flat one for the fill, and a bit of a drain around the edge, if you like. So that's okay. I mean, that'll bring through any triangulation you want. Fairly simple one in this case because we're going to put a building on it. So that we probably want to check it in relation to the actual ground surface here. And they're aligning pretty good. Mostly fill, a little bit of cut up the back. All right, so that being done, we can now start using that. So I'm just going to save that where we are. And we can start playing with it. So we have a Revit model we'd like to bring in and work with the surface now. It's a hospital, I believe, for example. It's one of the reference models from Autodesk that comes with Revit. So let's go and have a look at Revit quickly. Let's go and open it. Desktop. 2. And start files, it's this one here. Sorry about that. That one there, and open it. And this is actually a Revit structure model. It's not a completed Revit model. So if we bring in a 3D view, I know just enough Revit to get myself into trouble and to demonstrate this to you. So this is what we're talking about. It's not a complete. So it could be a representation of the building partway through construction. And there's no reason why you can't show that and work with that around Civil 3D and everything else. You may not have the whole model complete yet. So we're going to actually work with this in Civil 3D and Infraworks and everything else. So the thing about these is that to begin with, it's going to have this could be origin here, I think, perhaps, or the origin could be the bottom left-hand corner. It's not going to be in a coordinate system, so we need to coordinate the two. And there is a tool for doing that. So back into Civil 3D here, all we need is a common line between our civil model and our Revit model. Now we can actually bring in, if we like, an XREF of a drawing exported out of that Revit. So I'm going to do that. And I'm going to XREF in an exported drawing, that one there, which is just the base plan. Insertion point on screen, rotation on screen, go OK. And I'm going to position that on the site where I want it. Let's go for there and rotate it. Oops, that's a funny place to be. Rotate it to there, and then I'll just give it a little move. Okay, just for reference, this thing. So I'm going to put it there on my site. All right, so I want to draw myself a little line that is exactly the same length as what's in Revit. So I'm going to snap to that polyline. So it's going to be from this corner there, and make sure you do get the corner. If you don't get the size quite right, it goes into the wrong place in space because it's a different distance from the origin. Okay, so let's check the length of that polyline, which is 58.6825. So this says 58.6825. It's just rounded in Revit. So I'm happy with that. We're now going to need to elevate that as well. This is probably just at zero elevation. In fact, I'm pretty sure it is. When I pick that polyline, yes, it's an elevation 0. Now the platform is at elevation of 30. So let's make that elevation of the polyline to be 30 as well. Let's check that it's worked. Always check in the object viewer. And so, yep, that's in exactly the same plane. You can see it above and below. Good to go. I'm now going to unload that XREF. Oh, there it is. We can unload that one. Okay, so the tool is, it's a free download from Autodesk out of the Autodesk account site. And it is to go and in the toolbox here, you'll find this thing called Autodesk Shared Reference Point. Now, there's some good webcasts done by Autodesk on how to use this, but basically it's showing you the same as what I'm doing now. So we're going to export this coordinate system. So we double click on that to start it. It says select the origin point. So I'm going to do the left-hand end of the line. And it says select a point on the y-axis or the other end of the line, and make sure we do snap to it so it gets its elevations. So there's the elevation, Z elevation. It does have to be horizontal. It can't be a 3D polyline. Okay, and so that's what it's defined in origin, and this drawing is in meters, so that's okay. We're going to save that. We'll put it into, where are we? Desktop. Webinar 2. Put it into the start folder and my shared reference point. You can name whatever you like, but that will do. Okay, back in Revit, we can now import that. And it's another extent, the extension gets loaded onto Civil 3D and onto Revit as well. And this you'll find in the, Collaborate, is it? No, it's on the Manage. Nope, I'm going to remember the right one that it's on. Add-ins, I think. There it is. Import share coordinates. Now, you won't get this in Revit unless you've got the extension loaded. But we go import shared coordinates. Now, you can do this manually in Revit if you know what you're doing, but sometimes it's difficult to coordinate between different offices and things. So we can grab that endpoint, same one as we grabbed before. So it's asking for the start point, and now the Y point is asking for as well. So make sure we do snap onto the same one there. And now it's asking for the file that we just exported. So we put in the start, my shared reference point, and go open. Are you sure we want to do that? Yes, we do. So it's made a new coordinate system in Revit. So people working in Revit can continue working in Revit as per normal. But they now have, we go to the Manage tab now, under Location and Site, there is the shared reference point coordinate system. We can make that current and go OK. And what it means is they can continue working as per normal, but anytime that they want, they can come into the view over here. And here's the orientation. It's currently to project north, which is the origin close to the model. But if we put it to true north, now it's oriented the same way as in Civil 3D, and the origin's been moved a long way away. And now we can coordinate the two models using that shared reference point. So what can we do with that? Well, we can take this 3D model, for instance, and take it back into Civil 3D now. Now, you don't want to do that as the whole model. This is a huge model in terms of size for Civil 3D to handle, and especially if you export it to an AutoCAD drawing. What we can do, though, is export it as a Navisworks file. So I'm going to go export an NWC, which is a very lightweight file, but it has all the 3D geometry in it. So I'm going to put it in the start. I'm going to call it that NWC. I don't think we need to go into the settings for this one. No, I don't think so. So let's give it a go. We'll go save there. And that should now be using the coordinate system that I set to current earlier on. So it's coming through. Just about there. I think it's there. It's done. All right. So back down here in Civil 3D, we can attach an NWC as an XREF now, if you haven't seen that before. A lightweight 3D model. So these used to slow down Civil 3D ridiculously, not the NWCs, but bringing a Revit model in. Now we can go attach coordination model in the XREF dialog box. Go and find our model we just exported, open it. We don't want to change scale, insertion point, or rotation. We'll go OK. And we should find that it's gone in the right place. Now, these things, I don't think it'll show up in the object viewer. Let's give it a go. No, the object viewer doesn't like displaying those. So what we need to do, if we want to see it in relation to the rest of the model, we can pick parts of the model that we want. Now that's gone into 3D wireframe there, so I'll put it back into 2D. Right, so we can pick the at my surface there, as many surfaces as I want really. I'm going to pick the other one as well. We can pick that coordination model, and I'm going to isolate those objects. So I'm not trying to rotate the whole view. Now I will put it into, say, a realistic view and do a 3D orbit. And now we can start looking at these things together. Need to change the style of my other surface there, but we can start working these around. You can actually snap to that 3D model. We can go underground. We can see if we've got pipes and things going through here. If the foundations there, all the piles are going to be a problem. We can start working around here. If we've got places we know we need to get surfaces into or out of, we can check the levels are right. We don't have depressions in there. All that stuff can be done in Civil 3D, and it works very, very nicely. And, you know, obviously there's little lag, which is the whole reason for using that NWC. I'm going to go back to my 2D view. Once I've finished. You can actually snap to those coordination models as well. Zoom extents, and I'm going to end the object isolation to start working with it again. So we can coordinate now Revit in Civil 3D. Let's look at working the other way. Let's take this surface here into Revit. Actually, we might take both. So we can export those in the output tab of the ribbon. If you've got access to a folder, sorry, not the output, collaborate tab in the ribbon, there's this publish surfaces. If you've been given access to a folder in BIM 360 that the architects or engineers might be using, you can actually publish surfaces out of here. So I'm going to go publish surfaces, and I'm going to go and publish just the subdivision surface and the 12D one. It thinks it needs a rebuild, but doesn't really, unless it just touched it. Oh, yeah, I touched a face, that's why. And we can go and save that up in BIM 360. You can't actually, it has to be BIM 360 you save it to. Let's go for, where are we, BIM 360. My project files. I'll just put in Infraworks projects, I think, put it in there. And it's going to make, it's a drawing file, but it's a very specific drawing file made for Revit to read. Civil 3D won't be able to read it properly. So we'll call it webinar. Shared.dwg. All right, let's put it there. Go okay. Now it wants to have it in triangulated style. This subdivision surface was not, so it's actually going to do that for me. It's going to change the style when it writes the drawing. So that will work. Now the whole reason for doing this is to have it Revit be able to read those triangles and not change it. It always wanted to change the triangulation of a civil surface. Now it will take a little while for those to update. So just to save a little, well, about 5 minutes. Up in, to be usable up in here. So I did do one yesterday, which should just shortcut that for us a little bit. So if I go to the, now I've got to get this one right, manage, no, view, analyze, annotate, insert, yes, there it is, link topography. So it makes us a Revit topography out of our surfaces. So I'm going to go link topography. We'll see if that one's there already, but I haven't had a notification yet. No, it's still processing here. It's still updating it through the desktop connector. So we'll grab the one we did yesterday just to show you. Which I think I called test 2. No. When was it? October 22nd. We will. Actually, I think it's this one. Webinar finished. Yep. And we just link it. So you can navigate through BIM 360 folders there and link to it. So when it starts that link, think about it. Okay, it says it doesn't have the same coordinate system. They're not in the same spot. So it's going to align them. And so that's what we want to do. So that should be it. Telling me that they're not being displayed in this view. So let me go into the view settings, which are these ones, I think. No, they're not. Somebody who knows how to use Revit will be shaking their heads in horror at what I'm doing probably. But view template. No, it's not that one. Where was it? I remember where it was. Did find this the other day. Properties. No. Properties of the view is what I'm looking for. View template rendering. No. Visibility graphics, that's the one. All right, so down here, the topography won't be turned on. And I'll put on the triangulation as well. I'll try that. Oh, no, that's the wrong model. And no wonder that it was complaining about the visibility. Delete that. Okay, let's see if our other one's actually in there now. So I'll just delete that off. Let's go link topography. Sorry, I just couldn't remember the name of the one I did the other day. And if we go into Dean's project, that's where I put that other one, isn't it? I thought. Webinar. That was the one, wasn't it? And link that one. We should get a better result. Now we'll still say something about aligning coordinate systems. There we go. And you use the align option. You don't want to position center to center. There we go. That's better. And so you can see that if you look carefully, we'll do an orbit around there. The actual triangulation has been maintained. If we look at the edge of the, all that nice triangulation around those batter slopes and things has been maintained. We're actually looking at two surfaces at once here, but that's the sort of thing that Revit never used to do properly, and now it will, because we've actually got a good translation system. Okay, so they can obviously work with your surface in relation to their Revit model while they're working in Revit, and that's not going to slow down Revit either. So nice tools we've got there. Now that everything's coordinated, of course, though, we can do the same thing in Navisworks. So I'm going to save this. I might delete that out of there just before I do that, so we only get this. We could hide it, I suppose. Now we can hide it. Okay, so let's just save there. And let's go. Actually, do we want to? No, we've got that NWC out, haven't we? Yeah, we'll use that. Okay, so back into Navisworks now. We'll bring in that NWC that we exported before. So we'll append the NWC that we made from Revit and took into Civil 3D. That can go into here. There's our model. And then to get Civil 3D into here, there is a nice, if you've got Navisworks loaded at the same time as Civil 3D on your machine, or you've got the Navisworks exporters loaded, there is a command called NWC out. It's only on the command line. And I'm going to save that into my Webinar 2 start folder and call it the C3D NWC. And the nice thing about this is it lets you work with it more easily in Navisworks. If you just take a drawing file into Navisworks, the only way you can work with it is by layer, which is very time consuming. This NWC you'll see is all controlled by object, and so you can just turn objects on and off as you want to. You could turn off the display of the things you did not want to export. I believe it only exports what's displayed currently on screen, but I've just done the whole thing. Okay, and back in Navisworks now, we can append our Civil 3D NWC file. And there you go, straight away, bang, it's in. And so, if there are, because things are highlighted by object, I can pick something on screen. It tells me what it is. That's the subdivision surface. Okay, fine. I want to keep that one. What's this one? This is, oh no, that's also the subdivision surface. Oh no, that's the minor contour layer. Okay, so if I don't want to see that, I can hide it. And we can start seeing other things in here, and we can find things like all the polylines here. We should be able to hide those if we don't want to see them, and start playing out around in Navisworks. The alignments down there, we can get rid of those, and we start doing your clash detections and things as you normally would. Playing with Navis, but it's all coordinated nicely, as you can see. And so, That makes things all very easy. Actually, I can start there, leave that up for a minute. And the last thing I want to do is start bringing all of the stuff back into Infraworks. And so we can read in Revit models directly. So back into Infraworks. We could do a FBX export. We probably need to clear some space for our buildings. So I'm going to demolish some of the existing structures. We've had to buy their properties anyway to put this new hospital in. Just have this leak key here. That's probably enough, we'll see. And we can, because it's coordinated now, Infraworks has to be coordinated. We can go in and bring some more data in, which is going to be our Revit model. So we're going to bring in Revit, and we'll read, actually, we don't want that in there, do we? Delete that out and save it again. And we should bring out in the 3D model. Okay. All right, so going to our webinar folder on the desktop. Going to start. Open it. So, most of the time you'll see demonstrations done of, nice little buildings and things. Now, these buildings you can see here, if you don't have all the ones you want, you can sketch your own. Just simply by sketching, like I sketched those roads before. Yeah, didn't like that. Maybe because I've got Revit open, so I'm going to close that. Give it a few seconds. So you can sketch your own buildings like these ones here, just using the tools in Infraworks, and put in new proposed ones if you don't have a Revit model. Let's try and read that one in again. Revit. And so this one is as you saw before, it's just the structural model. So it'll be more of a representation of what it's going to look like when we're building this facility for all the residents to have a look at before it gets its facades and everything put on the front and gets itself tarted up. And that's a good reason for using Infraworks as well, to be able to give those sorts of representations during public consultation. Can this person that lives in this house over the back here actually see it when it's being constructed? They might be one of the major objectors. Maybe they can't even see it. So you've got to go and do these things in a 3D environment. Well, now that you're able to, it's very useful. You can do underground pipes and things like that can be done as well in Infraworks if you really want to. We should be just about there with that connection. And just while that's doing, let's have a quick look to see if there's any questions come up at the moment. Yes, this is being recorded. Yes, it is being recorded. So get hold of Dexter, or he'll give you some addresses to get hold of us at the end. Driveway curb let down in Infraworks. Don't think so. You could probably, you could do it with a component road. Be messy, but you could do it, I think, more easily than you can do in Civil 3D. How can I import surface from Civil 3D to Infraworks and have it adjust? So a surface imported from Civil 3D, not sure, I'll bring one in a moment. You can actually find them in this data sources. So you can right click on it and there's a re-import button in the right click menu. That should update your model. As long as you haven't renamed it, it'll reference the Civil 3D model. You do need to be reading the drawing though. Okay, so that hospital has come in this time. We're going to configure it. Basically, whoops. Sorry, just moving that. That's better. We need to tell it the coordinate system that it's in now. I get this right. They did recently change the way it reads in. So the Revit model is actually in feet. So we need to leave that in feet. We put the coordinate system in here. So you can click the world button to go and find them all, but we've got Mount Eden already loaded in there. And we set all these origins and things to 0, 0, 0. That should bring it through using that coordinate system, which is the one we set in Revit. So that being done, I think that's all I need to do. Go close and refresh. Hopefully everything's up the right way when we do it. Sometimes the origins, well, not origins usually okay in Revit isn't being up the right way. Things like Inventor, sometimes the Z-axis is horizontal rather than vertical, but you've got that in the configuration settings. You can change those. And we can also bring in, if we get time, we'll bring in a Plant 3D model as well. That's simply brought in as like an Plant 3D is based on AutoCAD, so it comes in as an AutoCAD 3D model, like you read in an AutoCAD drawing. Get there eventually, and there we go, all coordinated. Now these did used to have problems with the beams and things being so far away from the origin with the Revit model, they would be all skew-if and broken. These, they've fixed that, so it's really nice now. However, we do have a problem. Our foundations are half out of the ground because we haven't brought our ground surface from Civil 3D back in. So we can actually read the Civil 3D model directly now. So Civil 3D drawing, and when we read our model, which I saved on the desktop, I think, just make sure we've updated that, do a save. Don't think I need to close that, but I will anyway, just to save time, just in case. Desktop, and we call it webinar. And this will give us the link where we should be able to refresh that if needed. So what do we want to bring in? We don't want the roads. We just want our 12D platform here at the moment, but you can bring through whatever you've designed. Gonna go okay. It'll put that in as a surface under the terrain here somewhere. There it is. We go configure that. It should know what coordinate system it's in. We don't want to drape it. Yep, so that should be it. Go close and refresh. And we should see this terrain update. Now, it's not quite yet. It comes up with this message here, which means that you've actually got to go into here. You've got to find that surface and tell it what you want to use it for. We want to use it as a ground surface, and we want it above all the other surfaces in terms of stacking order, and we want to turn it on. Then this will update when I click OK. There we go. So now we've got our platform in there. If you look really carefully, you can see there's the edge of it. You could put a coverage area over the top of that to highlight it if you really wanted to. Okay, and finally, what is that? Okay, something's moved to my Revit model there. Or is that a, yeah, that is part of it. No, something has moved there. Not quite sure why. We can put in a little model here from, for instance, exported from Plant 3D. So let's go grab one of those. You just bring it in as an AutoCAD drawing of 3D objects. And we've got webinar 2 and start And there's a plant example drawing that I've got here. Or anything else that can be exported as a 3D AutoCAD file, plain AutoCAD. You can read in the same way, but that's how you bring one of these in to see it all together. So we can go and configure that now. I'm going to tell it to be part of the building, part of the buildings. And these ones probably won't be georeferenced, so you can use the interactive placing. And you can place it approximately where you want it. And we can, that should be all we need. Go close and refresh. And place it into position where you want it once it comes in. So it doesn't have to be georeferenced. You can manually place things if you want. So I can pick it now. Pick it. There we go. Give it a rotate. Placed against the wall. And continue on with it. Okay, so as a representation, here is our plant coming in. Okay, and finally, the whole idea behind doing this is that you can get your eye position down by some local part of the model and get a good idea from a human scale what it's going to actually look like as they're constructing this particular facility. So we did get there in the end. We're just about on time. We had a couple of questions there. I'll just see if there's any more that we haven't looked at. Recording. Yep, so it's being recorded. And cool, I think that's all the questions done. So